Orange Pod? Today we finished talking about exponents and multiplying by numbers ending in 0. Is that true or is that false? True. Yes. Okay, here we go. Let's go all the way down here to this. This whole thing right here is called a what? Power. And what is the little tiny number called? Exponent. And what is the big number called? Base. So power is the whole thing. Base is the big number. Exponent's the little number, right? Yes. Okay. And we kind of talked about all of these up here. We already talked about factor before, yes? All right, so let's go down to this. We'll come back to what that means in a second. Multiplying by numbers that end in a 0. What's 9 times 10? 90. What's 9 times 1? 9. So, in order to get 90, couldn't we just multiply the non-zero number 9 and the non-zero number 1 by each other? Yes. And then add the 0 in? Yes. What's 9 times 1? So I write down my 9, right? How many zeros are in this number? 2. So how many do I tack on at the end? 2. So basically what's happening is if you're multiplying by numbers that end in 0, you multiply the non-zero numbers first, so numbers that aren't 0, and then tack on the zeros at the end, yes? Yes. Here is our example, 60 times 20. Are these numbers that end in 0? Yes. Is 6 and 2 non-zero numbers? Yes. So what's 6 times 2? 12. How many zeros do I have left over in this problem? 2. So I just tack them on at the end to get my answer, yes? Yes. What's this whole thing called again? Power. What's the small number called? Exponent. What's the big number called? Base. Okay, so here's the question. What does the exponent tell the base to do? How many times to multiply itself, right? So down here on this problem, 4, let's just look right here, 4 to the power of 2. The 2 is the exponent, it's bossy, yes? It tells the 4, it says, hey, 4, multiply yourself. So it's 4 times 4, right? So 4 to the power of 2, the answer is technically 16, yes? 4 to the power of 5. How many times is the 4 supposed to multiply itself? 1, 2, 3, 4, 5 times, right? I should be up here. I should be up here. Gwen, I should be up here. So we got 4 times 4 times 4 times 4 times 4. And if you do all the math on that, you get 1,024. I'm not going to talk about it, but do you guys see a pattern here? Do you guys see a pattern when you go from 4 to 16 to 64 to 256 to 1,024? Do you see a pattern when you go backwards? Should we always be looking for patterns in math? Yeah, if you're stuck especially, should you look for patterns? So if you're stuck on a problem, we don't say try your best. We say beat the problem. And one of the ways to beat a problem is to look for patterns, yes? Yes? Yes. Down here, when you write out a problem in long form, what's that called? Expanded form. But if you just have the problem and the answer, those are called what form? Standard form. Say again? Standard form. And then I'm not going to talk about Adam's bike problem, but we did a bike problem here with Adam. If you read super duper carefully, we could totally solve that, right? Read, then what? Reread it, then what?